Which one has the lowest melting point? Which one of the following compounds has the lowest melting point? Let us see the matter. Which one has the lowest melting point? First of all, let us see the positions of halogens on the periodic table. Halogens belong to column 17 on the periodic table. Fluorine, chlorine, bromine, and iodine. We know that from top to bottom, atomic size increases down a group. So, fluorine is smaller in size like this. Then chlorine is a bit bigger in size. Bromine more bigger. And iodine is biggest here. And electronegativity of fluorine is 4.0. Electronegativity of chlorine is 3.0. Electronegativity of bromine is 2.8, and electronegativity of iodine is 2.5. Now, let us see these compounds. First of all, silver fluoride. Silver plus fluorine, which is smaller in size. Suppose this is electron cloud. Negatively charged fluoride ion and silver ion. This is electron cloud of fluorine, fluoride ion. Then silver chloride ion, which is a bit bigger in size. This is electron cloud, chloride ion. Then silver bromide ion, which is a bit bigger. This is electron cloud of bromide ion. And iodide ion, which is more bigger. This is electron cloud. Iodide ion. Now here, silver fluoride. As fluoride ion is smaller in size, electron cloud is strongly bonded to the nucleus. As here, less distance. Due to the less distance between nucleus and electron cloud is strongly bonded to the nucleus. That is why, in this case, fluoride ion polarizes a bit and silver fluoride retains its ionic nature. As fluoride ion is smaller in size and its electronegativity is higher. That is why fluoride ion polarizes the least by silver ion, and for this reason silver fluoride retains its ionic nature. Then it polarizes a bit higher than silver fluoride. It polarizes more than silver chloride, and in case of silver iodide it polarizes the highest. That is, here silver ion polarizes the iodide ion the most, because here the distance between nucleus and electron cloud is the most. This is most distance. That is why electron cloud is loosely bonded to the nucleus, and for this reason silver ion can polarize the iodide ion, which is very high. That is, in case of silver iodide, polarization occurs the most, and silver iodide turns into covalent in nature. silver iodide turns into covalent in nature, and silver fluoride remains as ionic compound. Silver fluoride retains its ionic nature, but silver iodide turns into covalent in nature. Now, which one has the lowest melting point? In case of silver fluoride, this is ionic compound. To separate these ions, high energy is required. As here, this is completely ionic compound. Positive ion and negative ion are strongly bonded to each other. That is why to separate these positive ion from the negative ion, high energy is required. That is here. In case of silver fluoride, melting point is very high. But in case of silver iodide, which is solid, suppose here n number of silver iodide molecules, comparatively less energy is required to separate these silver iodide molecules, because here among these silver iodide molecules only weak van der Waals force is present. That is why in case of silver iodide, comparatively less energy is required. That is, in case of silver iodide, melting point is the lowest, and in case of silver fluoride, melting point is the highest. This is because silver fluoride is completely ionic compound. It remains as ionic compound, but silver iodide turns into covalent in nature. Thank you for watching.